Welcome in Cool. Astronomers have been peering into space for over 60 years in search of artificial signals, and it's been more than 10 years since they come across the very first fast radio burst, FRB, in 2007. The second burst of radio emission have bewildered scientists by the mystery of their true nature, and as we just started to understand what's causing these strange signals, a recently discovered FRB has nearly brought scientists back to square one. At some point, humanity became obsessed with the possible discovery of other civilizations like ours, and now we're exploring space more than ever before with new advanced methods. One of the main ways to find an alien civilization is to look for FRB signals. Fast radio bursts are a great example of such signs. What's more, space is full of these ultra-fast bursts of radio waves that last just for a millisecond or two, and still, they are some of the brightest sources of radio emission out there, even once they travel for a billion light years through space. Now FRBs can be one of two types, repeaters and one-offs, which indicate their nature. Most common explanations for FRBs are based on cataclysmic events that happen in the vast space, such as a neutron star being swallowed by a black hole, a neutron star crashing into a white dwarf, or a supernova. However, these are usually sporadic FRBs, meaning they burst only once and then go silent forever. But if a fast radio burst occurs periodically, it's thought something out there controls these outbursts of radio emission. The great challenge when it comes to detecting FRBs is not only that they are located billions of light years away, but they are also extremely short-lived. Even such mighty signals that release the same amount of energy our star does in 100 years are too fleeting for us to thoroughly examine. So it seems you need an extremely advanced mechanism to catch them, and that's exactly the problem that Project Breakthrough Listen can solve. It is by far the most ambitious project searching for intelligent life that's ever existed. The project consists of telescopes and other tools capable of detecting a laser with power equal to an ordinary household light bulb at a distance of 25 trillion miles. Scientists in Breakthrough Listen plan to study about 1 million stars and even 100 nearby galaxies to detect any signals that could point to extraterrestrial civilizations. The hard part for the project's team is to identify so-called techno-signatures in a pile of countless radio waves caused by equipment on our planet, machines orbiting the Earth, and naturally occurring phenomena in space. So even with such powerful equipment, the Breakthrough Listen team has long struggled to find signals worthy of scientific attention. About 6 years had passed for them to finally come across something intriguing: the strange signal. When studying Proxima Centauri, Australia's Parkes Observatory collected about 25 hours of data, and as scientists took a profound look into this information, they stumbled on something strange. A wildly odd FRB signal occurred 5 times throughout that period. The object was named BLC-1, which stands for Breakthrough Listen Candidate 1. The signal is presumably coming from our neighboring star system Alpha Centauri and became the very first FRB that passed the project's filtering criteria, like disregarding signals with a constant frequency and those that are not fixed to a specific point in space. What caught astronomers' attention about BLC-1 was the signal's narrow bandwidth with a frequency of 982.002 MHz and the fact that it vanished as the telescope ever so slightly changed its focus to another point in space. To the best of our knowledge, such signals do not happen naturally. The only way to produce them is through human-built technology like Wi-Fi, GPS, satellite, or cell phone towers. Another weird thing is that BLC-1 also demonstrated a slight drift in frequency. Normally, such drifts signify either the Earth's movement or movement of an extraterrestrial source causing the signal. However, the drift is the opposite of what's expected. Instead of going down, it goes up. When something that unpredictable happens in space, it usually leads to something intriguing. This positive drift could be a result of a transmitter on another planet, or even a spacecraft that's accelerating in the direction of Earth at a consistent speed. Once astronomers compared the drift of the motion of the planets in Alpha Centauri, they did not find a single match, so there's also a chance BLC-1 could be reaching us from a tremendously distant place somewhere beyond Alpha Centauri. While the signal may not come from our neighboring star, it doesn't seem to come from Earth either. The true origin. So what's the true origin of BLC-1? So far, scientists cannot reach consensus. Some believe the radio emission is coming from some kind of technology that we put out there in space. Others speculate it could be an unknown natural occurrence. Still, the idea that the signal is a result of a specific device is the best simple explanation. Although the majority of theories are built around human interference like nearby microwaves, cell phones, aircraft, and satellites, there's a decent chance this was a postcard from another civilization, even if it's not a neighboring one. If that's the case, the Milky Way could be filled with intelligent communicating civilizations. Many wonder what would happen if we stopped guessing and just replied. If it was an attempt by another intelligent society to contact us, they've likely been around long enough in this 10-billion-year-old galaxy to develop advanced technologies. A positive outcome could mean humans learning how to survive for millions of years in the harshness of space. Now it's clear why BLC-1 drew so much attention, eclipsing other, but no less exciting, FRBs. One such signal was detected by the Canadian Hydrogen Intensity Mapping Experiment, CHIME, and tracked back to a spiral galaxy about 500 light-years away. This one has an unusual repeating cycle of about 16 days, active for the first 4 days, producing bursts hourly, followed by a 12-day break. Its origin is unknown, and no explanation fits. Another fascinating FRB revealed by CHIME in 2020 appears to come from a globular cluster near galaxy M81, one of the brightest in the sky. These clusters aren't known to have stars that produce magnetars, making it as strange as finding a smartphone in Stonehenge. FRB 20200120 could be a game-changer, raising questions about how magnetars form in aging star clusters and how old stars could produce such powerful bursts. Another staggering FRB, known as FRB 20428, came from the faint constellation Vulpecula. While a magnet to their points to the signal's origin, this FRB also carried a burst of X-rays, something never seen before, and was 3,000 times brighter than other FRBs. Conclusion. So far, the more astronomers discover about fast radio bursts, the weirder they get. These outbursts serve as cosmic camera flashes, revealing the universe's evolution, matter types, and distribution. Understanding them could make us confident space explorers. Around 1,000 FRBs have been discovered, but only 15 have been successfully located. While we haven't found an alien techno-signature yet, it doesn't mean we won't. It could be only a matter of years before we discover a potentially existing interstellar communication network ready to host us. Thanks for watching. Cool.